Hello, AP Calculus BC students. Mr. Record here. Going to take a look at our video 16, talking about limits of vector valued functions. So let's take a look at what the criteria says about how to find a vector valued function's limit. Now I'm returning back to the green box that we saw in a previous video, and I'm taking a look at this third portion down here where it says limits. And basically, if you've got a vector value function R, and you're going to take the limit, let's say as t approaches some value a. Well, you know that vector r is going to consist of a couple of different components. It's got this f of t component, which is attached to the I, and the g of t component attached to the j. Basically, you take the limit of each of those components separately, just like you did, say, when you were working through limits in the beginning of Calc AB, and then if the limit does not exist for either one of those expressions, then you know that you've got a vector value function's limit that fails to exist. Otherwise, if each of those two has a limit, your answer would be a vector that consists of those two limits answers attached to the I and j respectively. Okay, lot of information, but I think as you see it worked out in the examples, it'll make perfect sense. So here we go with our example 16. We've got the limit as t approaches 3 of t times vector I plus t squared minus 9 over t minus 3 times vector j. So what I typically tell my students to do is set these up as separate limits. Let's draw that arrow a little bit better here. So the limit as t approaches 3 of t. Well, that's a simple limit of 3, right? The limit of t when you let t approach 3. And then for the limit of t squared minus 9 over t minus 3. Now there's a lot of different, maybe at least two different ways that come to my mind as far as how you can handle this limit. One of which would be to perhaps factor the numerator into t minus 3, t plus 3. The t minus 3's would cancel, and then you're just taking the limit of t plus 3 as t approaches 3, which in that case would give us 6. But please note that because this limit produces a 0 on top and a 0 separately on bottom, two separate limits, you could use L'Hopital's rule. And the derivative of the top is 2 times t, right? The derivative of the bottom is 1. If we plug 3 in to the 2 times t, you're going to get 6 regardless. So because we have an answer for both of our limits, we can just toss both back in as the components of the I and j. Now understand it's perfectly acceptable if you want to use the vector bracket notation and say 3 comma 6 in that regard. Let's take a look at part B. The limit as t approaches 0 of e to the negative t. Now you're going to have to think about this just a little bit because this can be a bit tricky. But if you were to physically replace the t with 0, you would have e to the 0, and that can be defined as that function's limit there as t approaches the 0. On the other hand, when we let the limit as t approaches 0 take hold of sine t over 2t, we get an indeterminate form, as you can tell, a 0 divided by 0. And I would say probably L'Hopital's rule might be the best approach to this one. Otherwise, you're going to have to remember a tricky limit definition from the very early stages of Calc AB. And so if you plant in this 0 for the t, you get cosine of 0, which of course is 1. And then the 2 constant in the bottom. And so there we have 1 times I plus 1/2 times your j. And then finally, for part C, this would be a very good one for you guys to pause the video for, work through, and check your answer. Hopefully you're all right. Let's take a look here. When you find the limit as t approaches infinity of e to the negative t. It might be a little bit easier if you think of that as 1 over e to the positive t. Now when t gets to be super big, that's going to cause this entire denominator to grow super big, and 1 over something super large is essentially just going to equal 0. We're going to do the same thing with our limit as t approaches infinity of 5t plus 1 over t. Now, in this particular case, the infinity over infinity indeterminate form that we get will allow us to use L'Hopital's rule, and that limit would be 5 regardless. Or if you remember, whenever you're taking the limit as a value approaches infinity, you can compare the degree of the top and the bottom exponent functions, the exponent of the variable, I should say, and you have 1 and 1, which means you can divide the coefficients to get 5 in this case. So 0i plus 5j would be your answer. And we could just write that as 5j. Basically, taking a limit of a vector value function just consists of two separate limit processes, much like what you did in the beginning of the course, and then you rewrite your final answer as a vector. Hopefully this helps. We're going to finish up the video series with some talk about continuity and derivatives of vector value functions. Stick around for those videos. Thanks for joining.